Howdy and welcome back. So we'll get into some of the anatomy of a function template in C++ here. And we're going to start with a declaration of a function template. So this is going to be pretty similar to what we've already experienced with an ordinary function declaration, except we're going to declare, produce a declaration that communicates that it is a declaration for a function template. To do this, we use the keyword template, followed by the type parameters that we'd like to announce in angled brackets. And this is simply a parameter, whoops. So within the angled brackets, it's simply a parameter list of type parameters. And then there's also the ability to have a couple of different types of arguments, which we won't necessarily get into now. However, I mean, this is no different than kind of our parameter list that we've seen for a function. They're going to be comma separated. They'll have some sort of, I guess, type of the parameter that's being communicated. In the case of the template, we see that T is of type, is communicating a type. There's also the ability to have something like an int as a parameter to our template. So none of this is that new, but this header up here is, and it could come off as a little bit strange the first time that you see it, but this is simply communicating to the C++ compiler that, hey, we're declaring a function template here. And then the parameters that we're going to have to this function template will be introduced with type name within inside the angled brackets. So the keyword type name introduces a type parameter. Here, the single type parameter that's we're going to be using is going to be identified by T. And it doesn't always have to be a single type parameter. We could have multiple ones. We could have T1, T2, but T is going to be kind of the convention here when we're using, or when we're declaring a function template with a single type parameter. T, in this case, will represent some arbitrary type, and any type T can be used to actually instantiate this function template as long as the behaviors that are being used within the definition of this function template are defined for the type that's being used to fill in the placeholder of T. So the definition of our function template is going to look very similar. It's instead of our semicolon terminated declaration, we'll have after the parameter list some curly braces to introduce a function body, which will actually contain the definition of what minimum value is supposed to do. So in this case, we said we kind of had this generic behavior of calculating a minimum value of two objects of the same type. We can see here that this is a function template as communicated by this line up here. And then we can see that we're leaving open T as the return type, and then both parameters are also left open as type T. And again, when we instantiate this template for, say, type int, those T's would be replaced with int in the code that was generated by the compiler. One key thing here is that T must support operator, this operator. So if we're passing in a user-defined type, if T does not support the operator greater than, we'll see a compilation error because we're unable to, because the type checking would fail on the second round through. So using a function template, we'll say show the explicit way to go through this first, and then we'll talk about template argument deduction here shortly. So the process of replacing template parameters by concrete types is going to be called instantiation. To trigger the instantiation process, and this might be a little bit reminiscent of declaring, say, a vector of some type, because we're seeing these angled braces or angled brackets reappear here. So we would call minimum value of I, A and B, where I is the argument to initialize the type parameter T. So given this function template, if we call, so this is somewhere in our code where we're actually invoking that function, if we call minimum value int, the compiler is going to know that it needs to define, this version of minimum value. And this will happen at compile time. The compiler, as it's going through your code, will see here that, okay, minimum value is a function template. Oh, they would like to instantiate minimum value with int as type T. I'll go ahead and generate that code, and the compiler will generate this code for you. And again, before we had function templates, how you would have probably done this is create your own template, copy it in where you want to use it, replace, say, the template parameters such as T with the type that you were interested in. The compiler is doing that same operation, but it's doing it for you behind the scenes, so you need not worry about it. So this goes through the motions a little bit more. If we wanted to have a minimum value for, say, objects of type character, we would just go ahead and provide that information to the compiler in the angled brackets before the list of arguments that we're passing to that function. Same thing, if we wanted a version for integers, we'd go ahead and inform the compiler of that by placing int within the angled brackets directly after the name of our function and before the list of arguments. And same goes here for double. If we go ahead and look at this, we can see that, okay, doing this for character yields this definition if it hadn't already been defined. Doing this for int, the compiler will generate that code for us, and doing this for double, the compiler will go ahead and generate that code for us. So again, we're just specifying this template that's encapsulating some sort of generic behavior. And then we're just going ahead and invoking this using that template within the code that we're writing. And the compiler will be smart enough to know that, hey, if they're asking for a version to work with characters, I know how to generate that from the template, and the compiler will go ahead and do that for you. So with that done, I mean, I hope that makes kind of sense at this point. I mean, I don't mean to keep, going through this multiple times, but again, it's just a template. It's like let me think here. I don't know if you all have ever wrote like holiday cards or something to people, but you might have had some sort of holiday card where it's like, dear, da, 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 and then it's like the same content, and then, should we use, just use my email signature for lack of anything else. This would be a template, right? Because each kind of Christmas card that holiday card that we'd like to go ahead and send, I mean, all you have to do is kind of fill in this blank with the person's name. And if you have this template, it's very easy to do that. I mean, if this was a Word document or whatever, you'd go ahead and just create maybe one document per letter or per card of the person that you'd like to go ahead and write this to. And then once you've, say, created kind of a copy, you just go ahead and fill in the blanks within that template. So let's say, dear Prof. Challen, send that out to him. Yeah, cool. So I maybe that makes it a little bit more clear. I don't know. But again, it's just this idea of the template, and the compiler will go ahead and generate that. We'll go ahead and instantiate code for you from that template, so that you don't have to necessarily write it out each time. Okay, template argument deductions up next. Here we go.